Hello everyone. So today we are going to discuss about classification of signals. So we will discuss about classification of signals. The signal is broadly classified into two categories, that is continuous time signals and discrete time signals. So first we have to understand that why we need a such kind of representation of the signal. So I have already explained in my previous video that signal contains information about any physical phenomena. So that information usually has a pattern. So if it is a information, then it must have a pattern, and that pattern is basically either continuous time signals or discrete time signals. So we'll study that pattern and we'll say that we'll put it in continuous time signals and discrete time signals depending upon their nature. So what is that nature? Let's dig in much about the nature of that signals. So as it is self explanatory by their names, that continuous time signals is continuous in time, and in discrete time signal is discrete in time. So the discrete time signals is defined for discrete instances of time, whereas continuous time signals is defined for each time instance. And for each time instance, we mean that it's not necessarily defined for minus infinity to infinity time range. It can be a time interval as well. So if the signal is defined for particular interval, suppose we have an interval from minus t to t, or minus 2 seconds to plus 2 seconds, and in this interval, in this complete interval, the signal is defined for each instance of time. So if we pick any value inside this interval and if the signal is defined, so we can say that in this interval the signal is continuous. So for each time instance, it not necessarily mean that it is defined for every time instance. If it's an interval and inside that interval if it is defined for every time instance, then also it is called continuous time signals. Discrete time signals, whereas defined for only discrete value, and those value are integer values. So I'll give an basic representation which we usually use in literature. For continuous time signal, we represent the signal by xt, and the discrete time is described by the notation xn. Here n is integer. So if it is defined for only integer value, it means that it will be defined for some x0, x1, x minus 2, and so on. So they are only defined for discrete instances. Now we have already have our notations for our continuous time signal and discrete time signal as xt and xn. So these two signals are function of only one independent variable. But can all the signals in the nature can be described only with single independent variable? So that is not the case. Signals are represented mathematically as function of one or more independent variables. So it depends on what type of signal we are discussing. If we are discussing about speech signal, so it is basically a function of our acoustic pressure which we apply while telling some words with respect to time. So it's a single variable. But if we talk about images, then it will be two variables or maybe more. These variables are like the spatial variation of the image. So the signals can be represented as a function of one or more independent variable, but for the scope of this subject we are taking it as function of single independent variable, and that is time. Now one more point I want to discuss here is that some discrete functions, some discrete signals are discrete by its nature. Like suppose we want to study the nature of stock market every day, so it has some specific value for that day. Suppose Monday some value is there for stock market, Tuesday some other value, Wednesday some other value. So these are discrete by their nature only. But we can also get discrete time signals from continuous time signals also. So continuous time signals can also give discrete time signals, and it is very useful for signal processing. And how we do that? And that is done by sampling. It is very important topic, and it is very useful tool for getting discrete time signal from continuous time signals.